Hello everyone, welcome to NS Academy. So today we are going to solve this problem from the Tomato book, that is Test of Mathematics at the level 10 plus 2. This is a standard book for ISI and CMI entrance, so if you do not have it, you can check the description link and order it today. I would suggest that. So we are going to solve this problem, which is number 272. I am using the 15th edition because that's when I bought, but you can find it. So this is a problem regarding an equation and something we have to find regarding the roots. So in this problem, we are given the equation x cube plus 2x square plus 3x plus 3 equals to 0 and the roots are alpha, beta and gamma. We need to find this following expression. So if you want, you can pause the video right here and try it out. But what I'm going to show you is transformation of equations to solve this. Of course, you can do it by LCM, but that is going to be the long way and we never really appreciate long ways. Yes, of course it will get you the answer, but there are chances of getting mistakes a lot. So this equation, right? So alpha, beta and gamma are its roots. Remember, in transformation of equations, you define a new variable, let's say y, and if we define this variable like this, x upon x plus 1, what would happen is when you put this y into this equation and you solve it, completely simplify it into a new equation, new cubic equation in y, the roots of those new equation would be in the form of alpha by alpha plus 1, beta by beta plus 1, gamma by gamma plus 1, which is the significance of this transformation. And we want that because we really would get this thing as P, this thing as Q and this thing as R, and we are going to get a brand new cubic equation whose roots are PQR, from which it would be easier to find PQ plus QQ plus R cube. Let's do that. First you need to solve for x here, so this one is easy. You cross multiply to get x into y plus y equals to x, and then you get x times y minus 1 equals to minus y, or in other words x should be equals to minus y by y minus 1, or you can absorb the minus here and write this as y by 1 minus y. So we found out that we had to use the substitution x equals to y by 1 minus y. So the thing is, we have to put it here and make a new equation of y now. So put it here, you can get y cube upon 1 minus y whole cube plus 2 times y square upon 1 minus y whole square plus 3 times y upon 1 minus y and plus 3 equals to 0. Now, how do you do it? Obviously, you have to multiply both the sides with 1 minus y whole cube so that you can simplify and get a cubic equation. So when we do that, this term becomes y cube, this term becomes 2y square multiplied by 1 minus y, since the y cube 1 minus y whole cube and 1 minus y whole square, they cancel out and they leave you with a single 1 minus y. Similarly, here you should have 3y into 1 minus y whole square, right? Which is nothing but 1 plus y square minus 2y. And then finally you will have plus 3 into 1 minus y whole cube, which is 1 minus y cube minus 3y whole into 1 minus y, that is minus 3y plus 3y square equals to 0. We have to simplify this, and that is easy because y cube. First write down all the terms, 2y square minus 2y cube plus 3y plus 3y cube minus 6y square, and then from here plus 3 minus 3y cube, then minus 9y, and then we have plus 9y square equals to 0. Now collect all the like terms, y cube minus 2y cube plus 3y cube minus 3y cube. So these two cancel off and y cube and minus 2y cube will give you minus y cube. Then collect all the y square terms plus 2y square, and we have here minus 6y square, that is minus 4y square plus 9y square, that is minus 4 and plus 9 would give you a plus 5y square. Then collect the y terms plus 3y minus 9y, so it's minus 6y, and then the only constant is 3. Plus 3 equals to 0, multiply by minus to get the final equation, which is y cube minus 5y square plus 6y minus 3 equals to 0. So we had this equation after the substitution we did, which was x equals to y by 1 minus y. Now we know that since the roots of the initial equations were alpha, beta and gamma, this equation due to the transformation will have the roots alpha by 1 minus alpha, beta by 1 plus beta and gamma by 1 plus gamma. Let's call them P, Q and R. So what do we need to find? We need to basically find PQ plus QQ plus RQ. Now according to Vieta Relations, you can find the quadratic equations video right on the top. You can click that and see, but see after doing this one. So P plus Q plus R should be equal to plus 5 because minus of minus 5. PQ plus QR plus RP should be equals to plus 6, and then again PQR should be equals to 3, and we want to find PQ plus QQ plus RQ, which is our required answer, right? Well, you know the identity AQ plus BQ plus CQ minus 3ABC. This is a standard formula, and this is equal to how much? P plus Q plus R whole into P square plus Q square plus R square minus PQ minus QR minus RP. Plug in all the values and you should get the following answer: alpha by alpha plus 1 whole cube plus beta by beta plus 1 whole cube plus gamma by gamma plus 1 whole cube equals to 44, which is our required answer. So we used transformation of equations, we used the roots, and we used all these different formulas to arrive at the answer. This was the easiest way by far, I would say, because simplifying the first equation to begin with was not really the best way to do this problem. So I will come up with many more tomato problems and problems from ISI and CMI from the previous years, but let me know your suggestions if you have any specific problem or specific set of problems that you want me to explain or show me videos on. So I think that should be all for this video. Please do subscribe the channel and also like the video if you like the explanation. Thank you.